A block of mass m on a rough horizontal surface is connected to a ball of mass capital letter M by a lightweight cord over a lightweight frictionless pulley. A force of magnitude F at an angle theta with the horizontal is applied to the block and the block slides. The coefficient of friction between the block and the surface is mu sub k. Determine the magnitude of the acceleration of the two objects. So since the labels in the drawing do not coincide with the variables listed, so let's make it consistent. So this M here on the table is small letter m, and the ball that's hanging would be capital letter M. So we have to determine the magnitude of the acceleration of the two objects. But we have to take note that there is no given here value. It just says that there is a block. We don't know what that block is made of on a rough horizontal surface in which the surface also, the type of surface is not given, whether it's wood or cement or concrete or leather or anything. So which means that the acceleration will be expressed in terms of another variable lang. So we're going to make an FBD of the forces acting on the mass that's hanging and the mass that's on the table. Or if it confuses you to use small letter n and capital letter M, then we can just change the variables here. So we can just say that the block of mass m sub 2 is on a horizontal surface and mass m sub 1 is hanging, which is the ball. So let's consider first the hanging ball. So here, the two objects are connected to each other by a string, and the force here is exerted, making an angle with theta so that the two masses are pulled. So the hanging ball will accelerate upward, and the block of mass m will be accelerating in the direction of the force, horizontal direction. So the hanging ball m, what are the forces involved here? So for the hanging ball m, there is a tension directed upward, and there's the mass of the weight rather of m sub 1, and it will accelerate upward. So the net force is directed there upward. F net 1. So making an equation, F net 1 is equal to the tension minus the weight of m1. So F net 1 is m1 times the acceleration. That's equal to the tension minus the weight is mass of 1 times acceleration due to gravity, or T is equal to m1a plus m1g. Or you can also write that as m1 times a plus g. Now, regarding the block on the surface, block on horizontal surface, if this is our horizontal surface, then the mass is here, and so we have a tension directed towards the left. There's also a frictional force, Fk, directed towards the left. And then we have this force, applied force F, which has the horizontal component F, makes an angle theta with the horizontal, so horizontal component F cosine theta, and it has a vertical component F sine theta. Now, we also have the normal force, which is directed upward, and we have the weight of the block 2. And this block is, the net force of this block will be to the right, F net 1. So summation of the forces along the horizontal, okay, let's make vertical first. Along the vertical, there is no acceleration upward, so the summation of forces equals 0, meaning all the upward forces is equal to the downward forces. So upward forces is the net force, or are the net force, and the vertical component of the applied force F sine theta, and it's equal to the downward force, that's the weight of the second mass. So the normal force plus F sine theta is equal to the mass of block 2 times acceleration due to gravity. So Fn is equal to m2g minus F sine of theta. Along the horizontal, the forces are, the net force is F net 1. So F net, that's 2 rather. This is F net 2. So F net of 2 is equal to the forces directed towards the right, which is F cosine theta, minus all the forces directed towards the left, which are the tension and the frictional force, Fk. So F net 2 is M2A. That's equal to F cosine theta minus T minus mu K Fn. But we have here the tension, and we have here the net force, so we can substitute that. So we will just use the first one. We will not factor out M1. So M2A equals F cosine theta minus tension, because there are two terms, let's put that inside a parenthesis. M1A plus M1G minus mu K, and then the normal force is M2G minus F sine of theta. So M2A equals F cosine theta minus M1A minus M1G minus mu K M2G plus mu K F sine theta. So since we're looking for acceleration, so we're going to group together all the terms with the variable A. So we're going to transfer this to the left side. So M2A plus M1A equals F cosine theta minus M1G minus mu K M2G plus mu K F sine of theta. So we can factor out A here. Next, that's M2 plus M1, F cosine theta minus M1G minus mu K M2G plus mu K F sine of theta. So the acceleration, therefore, is F cosine theta minus M1G minus mu K M2G plus mu K F sine of theta divided by M2 plus M1. So that is how we simply express, or that would be our formula in finding the acceleration of the two objects.